Thank you, Tony. Yes, I'm Robin. I'm going to talk about future JavaScript stuff and most likely immutable data structures. So before that, hi, I'm Robin. I work at Bloomberg in a team called JavaScript Infrastructure and Tooling. I actually happen to have some colleagues here with me today, so you can chat with us. I'm also a TC39 delegate for Bloomberg. We'll get into what that means a bit later, but I get to participate into JavaScript standardization. And I'm also a co-author of the Record Tuple proposal, so we're going to talk about that today. And again, I'm not alone. I have one of my co-champions here in the room. So. Yes, so Record and Tuple. We're going to first go back to object types, how they're being referenced, how they are mutable today, and we're going to see on what is an advantage of that and what is an issue about that as well. Then we are finally going to get to talk about Record and Tuple. So that's going to be the big chunk of the talk, and then we're going to talk about when can you actually use it and related proposals. So let's go into it now, and let's talk about object types, references, and mutability. So you already know objects, you already use them today. That's the same with primitive types. And so let's talk about primitives first, right? On the first line, I'm creating a string here. On the second line, I'm also creating a string. Whether those two strings are equal or not, that is the question. And they are equal because they contain exactly the same sequence of characters, so that makes them exactly the same string as far as JavaScript is concerned. Okay, however, what happens with an object with a key that contains a certain value, and what if you create two of those objects and the key and the value are exactly the same? Well, they're still different because objects are being referenced by a reference that is being stored into those two variables. So the first object is different than the second object, and so that means that those two things are not equal as far as JavaScript is concerned. At least they are not strictly equal. And now let's talk about mutations. So you can try in strict mode to mutate some character inside of a string, and you'll see that you'll get a type error out of this. This is completely expected. So that means that over the lifetime, you cannot change what the value is for this specific string. For objects, that's different. Like, you probably already mutated an object in your life. This is a very common operation that you're going to change a key here. And that's fine. That's what we expect objects to do. And I think this is something that we have also seen recently, is people starting freezing objects. This means that essentially your object is going to be shallowly frozen, which means that you cannot change any of its keys. So when it comes to that, this is very interesting, but it's not deep operation. So this array inside of the object is itself not frozen. So in that case, that's a good thing, because I wanted to add my colleague Ashley. Actually, that's going to come later. But yes, in that case, I wanted to add Ashley to the list of my champions. And that's actually going to be an operation that will complete correctly. Okay, so this kind of creates a problem, because some of you have been dealing maybe with configurations or things that you don't want to get to change over the lifetime of the object. Right? For example, if I have this initialize connections function that I actually don't exactly know what it's doing, how am I guaranteed that it's not going to change what's in DB here? And the answer is I don't know unless I open the code for init connections. So maybe it will not change things, because that function might be actually nice and not do something crazy with the object, but it could do something crazy with the object I'm passing it to. And that is even if I freeze it, right? Because again, freezing is shallow. So what we could do is this. Yeah, it's not great. You're basically outputting a string and then you're parsing it. It's not good for CPU, it's not good for memory. So if you really want to do something like this, Please use structured clone. It's available in Node. It's available in most modern engines, and it's going to be a little bit more efficient than this. But if we could avoid this altogether, that would be really great, right? I wanted to also point out another problem with objects that we have today is that it's basically back to their referential aspect, the fact that if you create two different objects, they will never be equal because there are two different references. So here we have a nice boat with a really nice name, with really normal coordinates to actually say where the boat is going to be located. And we're going to start mapping out in an ES map the coordinate as a key to the location, to the boat itself. So this is OK if I reuse the exact same coordinate object that I had originally, and I use it for the lookup. I will find my boat. But let's say I create a copy for some reason, or I recreate manually the coordinates. So I get a new object. And this new object reference is not usable to do the lookup. Even if the value inside of the coordinates object are exactly the same as the original one, this lookup won't succeed. OK, so let's use JSON stringify again. It's really useful. I could just stringify my coordinates here and stringify my coordinates here. I have two strings that are equal. It will look up correctly, right? That's fine. Well, this is very, very shifty. So we could get in a situation where the insertion order, for some reason, is inverted. So in that case, well, the lookup will fail again. And this is the kind of really hard to track bug because, yeah, I'm serializing it to a string. It should work. But since the object is insertion ordered indexed, you're going to get in some situations where you're going to print two objects that have exactly the same values, but differently. So that's not great. And also, you cannot have object cycles. You cannot, get to a string and unserializable, etc., etc. So to recap things, when you have primitives, it's really cool because you hold values, and you cannot mutate them. When you have objects, it's a bit more complicated. I mean, you get references to those objects, and you can actually mutate them if you want to, unless you freeze them, and if you freeze them, it's only shallow. So that's one thing to keep in mind. OK, so this is the moment where I conveniently introduce record and tuple, and that's a good thing because that's the talk today. So that's a record. It looks like an object, except you have this hash character in front of it. This is going to make a huge difference. And so this is a tuple as well. As you can see, hash character again. This is an array literal. You put a hash character in front of it, you have a tuple literal, right? And you can combine them, right? This is a tuple of records. And now you have the other way around, where you have a record that can contain tuples. And you can do any combination that you want. The cool thing about them, at least for our purpose today, is that they are immutable. If you try to change a key of a record or a tuple, it's going to get you a type error. And it's a deep immutability. If I'm trying to change a record inside of a tuple, like I'm doing here, well, I'm also going to get a type error. Now, let's talk about equality, because this is very important. In the two first lines, I'm creating two arrays on the same line, and I'm comparing them. And they're obviously not equal from JavaScript's perspective, as we explained earlier. Same thing with those two objects. They are not equal. That being said, if I add the hash, then I get records and tuples. So for example, in the example of the record here, I'm associating the value 1 to the key A. And so if I have another record that's associating the value 1 to the key A on the other side, they are equal, because this is the same value as far as JavaScript is concerned. And same thing, if I put the two same sequences of 1, 2, 3 on both sides with a tuple, I will get the same equality. Because record and tuple are indeed primitives. So if I do typeof on them, I will get typeof of a record is record. Typeof of a tuple is a tuple. So let's go back to the issues that we had earlier, right? So the first problem that we had was this deep kind of configuration, Well, since we're fully immutable by default, I'm pretty much sure that init connections, if it tries to mutate my configuration now, it will fail at doing so, and it will raise a type error. So if I get to the assert here, that means that that's it. It's done. We managed to go through it without any mutation. And I don't even need to know how init connection is written. I will just know that since I passed it records and tuples, it didn't modify them. Now let's talk about our boats again. So now I'm just going to change my coordinate system to use records instead of objects. And that makes a whole difference, because now my copy essentially will have the same latitude and longitude values inside of it, which means that my second lookup now can succeed, because the map is going to compare the records by value instead of comparing references as it would do with objects. And so this is really practical. So talking about object cycles and unserializables, those cannot really exist in record and tuples. We don't have to really think about them. But what about the key ordering that we talked about earlier, right? That should be an issue. Well, the very interesting thing that we did is that because we foresaw that it was going to be a problem, records are not insertion ordered. So that means that every time you're going to compare two records, whatever the insertion order you did on them, they're still going to be equal. And as a matter of fact, if you run object.keys on them, it will always return things in lexical order. This is unlike objects. If you run object.keys on objects, they will give you keys back in insertion order. So this is really cool, but we have to kind of pay the price of them being records and tuples semantically. So the first consequence is that you cannot put objects inside of records and tuples, because if you would do this, they would not stay immutable. And so if you forget to put a hash in there, it's going to give you a type error. And that's kind of what we want, actually. Like, I don't think it's a drawback. It's just, it is very clearly a trade-off we're making here. That is a bit more annoying, I would say, that you cannot actually reference functions inside of records and tuples. And the reason for that is that functions are actually objects. So since you cannot put objects inside of records and tuples, well, you cannot put functions inside of records and tuples. We do have a solution to kind of reference them in a practical manner. That being said, this is way more scope for this talk. And so if you want to know more about how we plan to do this, you can go and talk to me. So now, we have another issue, is that since everything's completely immutable, and some of you that have been doing functional programming already, you already know how we get out of there, but let's go through it. If I want to add Nicolo and Ashley to the champion group today, the tuple here won't let me call push on it, because push doesn't exist on a tuple. Why? Because push is changing arrays in place, so we couldn't port it to tuples. So how do we do this? Well, you could just use spread. Spread will work correctly, and it will basically get you from one tuple to another tuple, and then you can spread those two tuples into another tuple. You get a new version that has the new values added to it. And so that will work consistently across arrays and tuples. And so you can also spread arrays inside of tuples, and you can also spread tuples inside of arrays. You can also do the same with records. Like you would just do with objects, you can spread. And so that means that if I just want to update one key, and so I want to keep those two, like the current state of the proposal and the next state of the proposal, because we're not there yet at the next step. I'm going to get there later, but right now the proposal is at stage 2. Hopefully soon it will be at stage 3. Before we can say this, we still need to keep the old version here. So we created a new copy and we changed the value essentially. So beyond spreading, we have different things that we want to do. For example, on array, you have array prototype.reverse. And reverse is interesting, but it also changes things in place. So we cannot, again, change the tuple in place. So we created a new method that's called toReversed. And that instead of changing the tuple in place, it will apply the reverse operation on the tuple and return you a new one. That's it. It's as simple as that. So we have toReversed that is reversed but not in place. It returns a new tuple. We have toSorted that's doing the same thing as sort, but again, not in place. It returns a new one. And we have .with that's doing the equivalent of an indexed assignment. So this is essentially going to do the same operations as using the brackets. And finally, we have toSplice that's doing whatever Splice is doing, and I'm not going to go more into details about Splice. OK, so this is really cool. So what would be even better is that if we had those functions with arrays. And well, we kind of wanted to do this, and so we added them in another proposal. So that's it. I could write this sort by name function that you're seeing here that's going to work on either array of or tuples being passed down to it. So if I pass a tuple to this function, it's going to work. If I pass an array, it's going to function correctly as well. So we have Rick and Ashley here passed as an array of objects. And here we have Rick and Ashley passed as records and tuples. And I'm very sorry, but that's the joke. You're lucky because I couldn't get the rights to put it like in audio for everyone here. So, but I hope you have it in your mind playing now. OK, let's do a quick summary. You add a hash, you get a record or a tuple. That's simple. They are immutable. They are actually deeply immutable, and then if you want to update them, you can use spread or tuple methods that are also available on arrays and typed arrays, actually, I forgot to say, which means that you can write interoperable code. Then, instead of referential equality, you get value equality. And that value equality happens at all levels of the language, including, obviously, strict equality with triple equal, but also in ES maps and ES sets that will actually use the same semantics across the board. And they can't contain objects or functions inside of them, but we might have a good way to reference objects and functions inside of records and tuples in the future. So what's the state of the proposal? Because some of you might be anxious to use it. So record and tuple is a stage 2 proposal at TC39. What is TC39? TC39 is the standardization venue for the ECMAScript language. The trademark oracle for JavaScript. And stage 2 means that out of 4 stages, it means that the committee expects the feature to ship one day. So the basics on the proposal have been agreed, and we're just trying to define it clearly right now. And we did a lot of work to define it pretty well. So the proposed spec is being reviewed at the moment. We have already 2 out of 3 reviews that have been finished. We have a Babel transform and a polyfill for it. We have started on test262 spec tests. They are not integrated into the test262 test suite, which is the standard test suite, essentially. But they're ready to be integrated. There is a Firefox implementation behind the compile time flag in Firefox that I think now is also supporting JIT optimizations. And so what does that mean for you? When can you use that feature? Well, for experimentation, we want you to try it now. Like, take a picture of that URL right now and go there and try things out because this is the last moment we can get feedback from you, because once it gets to stage 3, it's going to become increasingly more complicated to make deep changes to the proposal. So that being said, experimenting is fine. Using the feature in your projects is really dangerous because, as I just said, stage 2, things can still change quite a lot. So that means that it's definitely not stable. And what about the new array methods from change array by copy that we showed you earlier? Well, I'd say you can use it for new projects now because we have polyfills that are available. It's shipping in Safari right now. It's also shipping in Bun if anybody cares about it is in NodeConf, but you know, since it's using JavaScript core, it's in Bun. It's also in SpiderMonkey, but behind the flag, unfortunately, but it should be switched off quite soon, switched on quite soon. And for V8, work is being tracked, actually, and the V8 team is actually working on it. So it's hopefully going to be available in Chromium and Node and Dino soon. So for existing production projects, I would just wait because you might not want to work against polyfills for existing projects. That being said, I'm almost at time, so I want to thank everyone that worked on this. Like, I'm not the only one working on this, far from it. First of all, we have Rick, who's been my co-author from the beginning of this proposal. He also wrote the playground that you're going to try, and Rick is also in the room. So if you want to ask questions about Record and Tuple, is absolutely super knowledgeable about it as well. So don't hesitate to go and bother him. Sorry. And Dan, who's not here today, but also works at Bloomberg, has been our mentor throughout the process and been reviewing the early drafts. Then we also have Nicolo, who's working at Igalia and also is a Babel maintainer. He has been reviewing our spec. He also has been doing most of the first implementation for SpiderMonkey in Firefox. Ashley, who joined Bloomberg now more than, that joined our champion group more than a year ago now, I think, has been working a lot on finalizing the spec, has been doing an amazing job. That's very difficult because spec text is an animal on its own, to be clear, and has been finding a bunch of edge case in our proposal here. And I wanted to thank also a few of the implementers that have been working on it. Tim from Igalia has been taking up the JIT work for the SpiderMonkey/Firefox implementation. And Aditi has been implementing change array by copy in JavaScript core. So that's why Safari is the first browser to ship it. But that's really cool. Finally, I wanted to thank you here at NodeConf EU. For your attention today and listening to me talk about new stuff. So I'm Robin. I work at Bloomberg. You can find me on Twitter. You can find me on GitHub. You can find Bloomberg at this address, but you can also find us at the booth that we have here at NodeConf. And yeah, come talk to us. We are obviously recruiting, and we are also super interesting to talk about anything from Node, obviously, to JavaScript standards, web technologies. Yeah, we're pretty much interested in all of that. If that's it, I can, yeah.